Okay, last part. We're going to look at a little advanced example with evaluate dat. Throughout the course of these um, 4 parts, we've kind of covered these new Python little snippets that will be really useful. So not just for DATs, but this sort of a thing, very common. And then specifically for DATs, like this .num rows is very useful. And then just specifically this idea of using the brackets for row number, column number. But if we look at, so in this file, I've had this arrangement here. We've talked about all of these more or less. In future videos, I'll focus on these execute dats. So these are for writing Python scripts that are triggered on various conditions, depending on what happens in chops or other dats or other parameters, whatever. And then, so for now, this eval, let's just see what this is all about. So this is based on, just go right in here. This is based on a tutorial by Matthew Reagan. He's one of the greatest touch designer devs. He's done lots of really great tutorials. He's got a lot of good ones specifically on Python techniques. But for this one, it's doing a little data viz for temperature. So I have this constant here, and we can cycle through the different months. So let's just go through January, February, right? And so this is all kind of based on a text file that has the data for all of the months. And I think this was from some city in Arizona. I forget which one. So it's pretty hot. And so it's looking at the data. It's shaping the sizes of these rectangles. It's changing the text down here. It's changing the numbers right here. And also it's changing the position of the numbers here based on how tall all of these are. So let's see, right now we're still at the end of January here. So let's look at Jan. Let's just see what happened here. So file in. Okay, let's see where our assets are. Data. And here we go, temperature. So we have this arranged. There's tabs in between all these things. This little number 0 here is just a placeholder, essentially, because this is kind of the column for the months, and then average high corresponds to this, and average low corresponds to this here. So that's just kind of a placeholder with an extra tab. When we read that in, so this has a convert. So again, I think probably that we could just do it like that instead of using this convert. But whatever, I'm just in the habit of using the convert dats. So evaluate dat is right here. So what it is doing, if you kind of see the difference here, so I've got our numbers for high and low, and then here inside the eval, those numbers seem to have been normalized from 0 to 1, so they became these sort of floating point values. And if we can kind of see, so July, the high is this 1.0, because if we see July average high, so this is the highest value. So this was kind of important to note. This becomes our maximum for the whole table. And then everything else is kind of a fraction of that high value. So how do we do this? 'Cause, we needed the values to be normalized as a float number from 0 to 1, because eventually we're going to go over here and we're going to kind of look at this. We're eventually scaling the y scale of this rectangle based on that value. So that's why we needed it to be from 0 to 1. But let's see what we're doing with the eval dat here. So what happens is we have 2 inputs. If I kind of scroll a little bit here, input 0 is the data. Input 1, expressions. So this we create a new table here, and this is essentially doing mathematical expressions to all of the input cells. And the way we did this is, because this one has what would be 13 rows. It's got 12 months, and then this kind of top row. And here I only have 2 rows, but essentially what it does is it will kind of repeat this bottom row and keep doing it over and over and over for all of the subsequent rows. So the top row here, me.input cell, all it does is just copy over exactly what is coming in from the data, right? And then for the entire column 0, all it does is just copy, it displays whatever the input cell is, which is the month name. So we can see the month name right there. And again, dot input cell. So if we did something like this, click on Python help, and then we can go through here. So, okay, input cell, that's where we find out about that. From the cell, you can get da, 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 da. Okay, it's got info right there. But the thing we care about is, okay, how are we doing this mathematical operation? And that's with, these two, we have the same thing. So actually, let me change this a bit. Let me not do the round to start with. Oops. Okay. And so just me.input cell divided by 105. And that gives me these insanely long float numbers. Because you can see, basically the way to normalize it from 0 to 1, you divide it by whatever the highest number is, right? So there you go, simple division. A truly smart system would automatically find out what is the maximum value in these cells instead of writing this 105 manually. We would, there's various ways we can do that. We can do that in another Python script. We can convert these numbers to a chop, do an analyze chop, and find out the maximum that way. But okay, let's not worry about that right now. Right now we're just doing this math. We don't need, like, how many decimal points is that? That's way too many. And so we do this round code. So again, like this code round, like how did we know that this was possible, right? How did I know that was even like a thing? We can search Python round function. So with some exceptions, typically any sort of Python code that works out in the world of just normal Python, it works in Touch Designer. So if you think, okay, I want to use a Python script to round something, you can look up. You don't have to look at a Touch Designer specific website or tutorial. You can look at this right here, and so you can find out. So what happens is, here's the number that you want to round, and this is how many decimal places you want to round it to. So pretty simple. So this is rounding it to 2 decimal places right here. We can see, boom, boom, beautiful. If I did 0, that is just rounding it up. Okay, that's not that cool. Great. So we can play around with different things like that. Okay, cool. I think 2 is good enough for us. So that's why we're using the eval. So let me just copy this. We need to get that back. Okay. So super. So now, so eval is doing this math. So it's in a more kind of complex way. If I did something like, let's do a dat2. Let's imagine I'm going to convert this. So then it becomes kind of tricky. Actually, let's do it like this. Let's do another, because I want to like select this. Okay, yeah, let's do it like that. So dat2, and first row is names, first column is names. I want a different channel per column. Okay, there we go. So now I have average high, average low. That's pretty cool. And I could do something like math. So range. So what is it? It's like from 0 to 105, 0 to 1. Okay. So that's actually doing what I want it to do. Okay, cool. But then I need to, okay, and then I'd have to kind of get it back to a dat. So it works. It's another way to do things, and in some cases, maybe it's really nice to have this data as chop channels instead of a dat table format. Whatever. It's just a different way to do it. Up here, so this is the same old thing. end row copying whatever start row is. Start row receiving a reference from a chop, which I have my constant chop here. I can write whatever number I want. End with a null. Okay, and then this is the magic right here. And then really quickly, this is kind of just top stuff. I've got this ramp. I think I made these 100 by 500, like all of these. And then just setting the ramp color manually. So that's the high, that's the low. And then just using a rectangle. And the transform right here is what's changing it up. So if we, by default, if I did get another transform here, and let's see what happens. Put that in right there. So you can see if I change the scale, let's say I do like that, you see how it's kind of anchored in the middle of the rectangle, which for this, I don't want that. I want to kind of be anchored at the bottom, and then the rectangle gets taller or shorter, depending on what the temperature is. So what I did right here is you can see the pivot is changed. So the pivot is basically what, it's like anchor that you might see in other applications. So a pivot of 0 means it's the bottom of it. So that's why this is changing. And I can just kind of just show this right here. Pivot by default is in the middle. And now if I do this, we can see it's going up and down depending on all that. Beautiful. And again, like these things can change by default. It's set to fraction, so that will go from just 0 to 1. If you wanted to specify pixels, you can do that, but fraction just 0 to 1, I think is easier to wrap your brain around. And then, once we have this ramp, we have, so this is essentially becoming a mask going into a multiply. I could, like with many things, I could do a composite right there, set to operation multiply, does the same thing, whatever. This isn't cooking every single frame, so really it makes really no difference whatsoever as far as computation. So this is doing the same thing. So transform here, it's grabbing, so column 1 is the high, so this is grabbing column 1. Down here is going to be the low, so it's grabbing column 2. So it has the value of 0.4, you can see, great. And then I'm sending these, so these are still 100 by 500, sending it to a fit top. So this is setting the resolution to 1280 by 720, keeping, I think by default, it'll be to like fit best usually. So that's actually kind of stretching it, but I changed it here, native resolution, and I kind of used the translate here to move it around to where I wanted it to be. And everything else just kind of kept it the way it is, and then just put these together with an over, whatever. And so the text here, so this is actually a text top. And so for here, for this text, I don't want to be showing this normalized value. I want to show the actual temperature value, right? So I'm looking at, so this becomes a little complicated, right? So I'm looking at that convert 1, which still has the numbers as actual temperatures. And then what? Okay, I need to find out which row I need to look at. So I'm looking at that constant that I'm setting, the month. I'm converting that to an integer. So like I showed before, like the chop. So even though this looks like an integer, this is actually 2.0. And if you try to send 2.0 to reference a kind of row, that's going to give you an error. So you have to specify, convert this to an integer, like so. And then that's looking at column 2, which is the low. Okay, great. So that's grabbing that number, 42. Great. Are we in February here? 42. That's it. And high is doing the same thing up there. And then, so for here, I could have used a fit top in the same way, but and we could have done the translate thing and figured out whatever. I had previously had this as a kind of a crop to expand it to 1280 by 720, and then I'm specifying here in the transform that I'm changing the y a little bit based on how tall the rectangle is, because we don't want this number value to be stuck in the same place, and depending on the temperature values, you can see it goes up and down. So I need to change my translate y depending on the height of this thing. And so I am looking at, and here I'm translating not by fraction, but in pixels this time, because I'm looking at the height of high. So what is that? The height is 500 times null 5, row 0, column 2, which is right here. So this becomes 500 times 0.57 equals 285. Beautiful. Okay. So that's how I'm kind of like shifting the ty of these numbers. Okay, so you got all these arrows, references going all over the place, but it becomes kind of a cool little viz. Of course, then we could, next step would be maybe build some other buttons or interface to go through the months in different ways. Or maybe we have an LFO with a count. It's counting through the months, 1 to 12, whatever. Okay, cool. Look at Matthew Reagan's stuff. He has tons and tons of great tutorials. Okay.